We will have a short view to the EyeVision 3D instruction set and data streams, the image sensors, and how to operate on point clouds. What's also interesting, because based on the discussion, we can, of course, our mainstream and what we are doing mainly is we work on point clouds or profiles. But of course, we can work on depth images or on intensity images of 3D sensors. Of course, the depth image and the intensity image is a kind of gray image, and we normally forget always to mention that we of course can work on these images. Many of the solutions which you can find where people using 3D sensors today, say using the depth image. But the main advantage of 3D is if you have a point cloud, because a point cloud can be modified and oriented so that it works perfect for the solution. This is what simply is forgotten when people say, oh, we do 3D but we work on a depth image. Of course, a depth image has the height information, but if you have maybe not a flat part, then the depth image, like the gray image, the gray scale is moving away and you cannot work with it. Maybe it's somewhat clearer if you have a look to the demo material, which we see later. Here is an example for a point cloud. You see here a part which is anywhere in the room, and we can, for example, measure the diameters of these two hoses and relate it to the rest of the body. So this is only to give you an idea how a point cloud, you see it today everywhere, but it's not so often used. Maybe we have a look to a point cloud in a few seconds. So what's really important is we have our, let's say, toolbox. And of course, today we have a close look only to this 3D section. And I say only to this 3D section. You see, if we open up the 3D section, we find all kinds of tools to operate on point clouds. And of course, also on profiles. Profiles at the end is one section of a point cloud, if we want to have a look like this. But in many cases, profiles are directly generated from profile sensors, like triangulation sensors. If you connect multiple profiles, then you get a point cloud. So that is nearly similar to have a multiple profiles in a point cloud, vice versa. That's why we mentioned it about. And of course, if you have a depth image or a 2.5, some people say, named it also 2.5D image. You can use also all the gray image tools, because in the depth image is at the end a kind of gray image, and you can work on the gray images with the standard 2D tools. And one additional nice feature is some of the especially triangulation sensors generate also an intensity image. An intensity image is the brightness at the laser point in this case. And this allows the user to do also 2D evaluation on a 3D part. Normally, if a printed value or some prints on top of a part cannot be detected with a point cloud, with a 3D sensor, because the print height, depending if it's a laser printer or whatever, is anywhere below of hundreds of a millimeter. And of course, there are some sensors which are able to have this resolution, but then they are highly specialized. But the intensity image at a special point of the scan generates also the brightness value, which, for example, if you have a DMC code on it, you get the DMC code in the intensity image. This is a second image which belongs to the point cloud or the 2.5D image, and you can operate on it with, for example, if it's a code, you can use the code reading tools, which are also part of the software. You can see here code reader, and you simply can use for example, the DMC code reader to read the DMC code on the part within the 3D part. So, and of course, you have all kind of color and gray image tools available. If you have these colors here, they are normally randomly generated based on the height information. There's a tool which allows you to connect special height information to special color. This is the major improvement is for the user to have a feeling about the height. The algorithms don't care about the colors. So of course you could use the colors and say, okay, I search for the green parts, but at the end, if you have a point cloud, you want to operate on a set value, and the color represents a set value at the end. So here is one example. In this case, it's from Intel Realsense. As I mentioned, we support a lot of different sensors, and one of these sensors, or the cheapest sensor, is the Intel Realsense family. In this case, it's a stereo pattern-based stereo sensor, D420, I think so. And this sensor generates, beside the point cloud, also a color image and a depth image. So in this case here we see the color image, and we also see a depth image. And the interesting thing on the left side, you have the set values. That means we can see we have the bottom part of the box, and above the bottom part you can see it slightly in the color image. You have a box with the same color like the outer box, but you see here in the depth image, okay, there is a different height, and on top we have the box, or an Intel box, and the height is much higher. So if you want to evaluate this kind of stuff with a color image, for example, it's really difficult, but in 3D it's very easy, because you get the real set values. That the surface is not so nice, it depends only on the resolution of the sensor. There is a higher resolution sensor also from Intel. It's called also Realsense. We see it later. I've forgotten the name of it. Anyway, and to get the better resolution. At the end, it's important which sensor is the right sensor for your task, means what is the resolution you need in Z, X, and Y dimension. So image sensors for point clouds. So we have these profile sensors. I mentioned it today. We have a look to these different options of profile sensors, and we have these different 3D area sensors, and then some other sensors which generate a point cloud. Of course, finally, if you want to do it, and that you have one of the newer iPhones with LiDAR technology, like the Intel sensor, which I missed, the Intel LiDAR, but the iPhone has also a LiDAR sensor, you could simply use a program to capture these images and transfer it to the software, because we can read the standard PLY format, and you can also operate on images which you have generated with the iPhone, for example. So you have a real wide variety of options. So the resolution of the iPhone is not so high. That means you have always taking care that the resolution, that what I mentioned before, that the resolution fits to the needs you have. And therefore we have now a close look to the different options. So the standard option in industrial application is today based on the resolution, the triangulation access. For this triangulation access, we support the standard. The main focus companies, this is automation technology. What means the discrete access means you have a camera and a laser, a line laser. And you, based on the triangulation, you get the Z values. This is done within this camera. It could also be done with the EyeVision software. If you use a normal camera and a normal line laser, we have this line extraction tool, and of course, more important, calibration, so that you get the calibrated point cloud. The same access, so this here is one set. You can buy this camera, you can buy a line scan laser, or you can buy a set which is pre-calibrated, or you do the calibration by yourself if you buy this one, or you use, as I mentioned before, a normal camera and a normal line laser, and make your setup by yourself. You see here a slight angle. This is the Scheimpflug angle. You don't need it. It depends on the accuracy you want to have. You need it or you don't need it. It's a kind of discussion. But at the end, for the principal triangulation, you don't need this. What makes it special, or what is one of the major features why you don't use always, let's say, a standard camera? Because it's much cheaper, of course. These specialized cameras are mostly in a price range about 6,000 to 9,000 euros. But at the end, this means 200,000 lines per second. Normal cameras deliver maybe 500 lines. 200 lines per second means also 200,000 lines per second means also 200,000 area images, 2D images per second. And this is a real high constraint to capture images and extract laser lines. If you don't need this, then you, of course, and if you have a slower speed requirement, then you can use also standard cameras connected to a PC and do the rest in the PC. So these cameras can do it. For example, this photo focus camera has 150 frames per second. It's not so fast. Or the SIG camera has up to 46,000 lines per second. If you need some special capturing cameras, then you can use these. Or as I mentioned before, because you have EyeVision, and if you have maybe you need only 20 lines per second, a cheap access is you use the Raspberry Pi, for example, or any other embedded system. But I think it looks nice. So we have in the EyeVision software all the tools, including the calibration, also the laser line extraction, so that you can build your very cheap triangulation system. So you simply use the Raspberry Pi, you buy anywhere a laser line. It should be a good one, or if it's not so good, the 3D point cloud is not so good, but at the end it works. And then you can make your own 3D triangulation scanner. Because at the end, the difference between this one and this one is the speed, of course. These MIPI cameras at the Raspberry Pi delivers you 20, depending on the sensor, 20, let's say, to 100 lines per second maximum. And if this is fast enough, this works. Or you use any normal camera. You can use any normal camera and a laser line and do it with the EyeVision software. This is only one example for a discrete setup. In many cases, if you build machines and you want to replace, you want to have the option to replace the cameras if they are damaged, or you don't, you want to prevent that users of the system prevent it from working, because the major problem here for these discrete systems is if a user is adjusting the lens is here in a direct access. If you move the lens, if you turn in any case one of these lens wheels to adjust it, you have to recalibrate it. And really, calibration of a 3D sensor is not so easy. Of course, we have built it in the EyeVision software, but it needs a little bit knowledge and time. And in most cases, you don't have the knowledge, the end customers don't have the knowledge and time, but they always like to play around with everything what they can play. Therefore, the compact sensors are right now the mainstream for triangulation. And here are the major brands which we are supporting. So we still add new sensors if they are available, also for third-party software, to allow you versatile access to all these different manufacturers. Here are some of the scanners from automation technology. As before, the major difference between this one and these triangulation sensors is you have the laser and the camera. You have these two glasses here. Behind one is the camera, behind the other one is a laser. So that means the end customer cannot modify it. So this camera is ready calibrated. You can attach it with the screws to your machine. And if it's for any reason damaged, you can replace it simply with the next sensor, and you don't have ever to recalibrate it by yourself. And of course, nobody has the access to modify anything, so it cannot be decalibrated. The same advantage is for the following triangulation sensors from all these different manufacturers. For the Saturn, I will have another short intro in a few seconds. Here are simply some other triangulation sensors. At the end, you see always the same thing. You have on one side a laser, on the other side the camera. It looks sometimes a little bit different, but it's always exactly the same. What is the advantage of the Saturn 3D? This is a sensor where the built-in CPU is available to the customer. In this case, for us, that means, as I mentioned, we have these smart 3D sensors, and the smart 3D sensor expects that the EyeVision software runs inside of the smart camera. And in this case, the EyeVision software, the profile section of the EyeVision software runs in this smart sensor that you have a 3D smart camera. That's the difference to all this. You can run it either as a normal 3D camera, or you can use it as a smart 3D camera. And so after these triangulation sensors, of course, there are some others. For example, this focal spec camera. This is a real nice high resolution camera. The company belongs now to LMI, and the real advantage is the set resolution of 0.66 micrometer. It's the highest resolution in this area. So of course, the field of view is smaller, but in many cases it has a lot of advantages. So, we have these time of flight cameras from, for example, Basler. There are different kind of Basler time of flight cameras. as we can see here, or we have these from Bicom. This is a camera from Austria, or we have the Lucid Helios time of flight cameras, and there are some more, but these cameras are right now supported from the EyeVision software. And of course, there are some different cameras built around the shape by shade technology from, for example, Wrangler, LMI. So for the advantage for the EyeVision users, you simply connect these cameras to the EyeVision software, and at the end you get a point cloud into the EyeVision software and can operate, and then you can operate on these point clouds. So you don't have to care about the manufacturer and whatever. You simply have a point cloud and you have a look to the sensor about the resolution of the sensor, and then you can say, okay, this sensor fits to my needs or it doesn't fit, and if it fits, you simply can use the sensor which you like. It's the same like I mentioned before, the Intel Realsense. Unfortunately, Intel discontinued this sensor because it's, why I thought, unfortunately, of course, the resolution is not the highest, but for many cases it's enough, and the price-wise, it's one of the cheapest sensors in the market. Still in the market, it's roughly about 200 euros, 150 or so. Or the LiDAR version of the sensor with a much higher resolution is about 400 euros. Of course, in the near future, you cannot buy it again because Intel discontinued the Realsense series, and it's difficult to use it for industrial solutions if you have to deliver for a while. Of course, there are some stereo vision sensors. This is a stereo vision line scan camera with a very high resolution but a small depth field of view. And we have, for example, also the Nerian cameras and so on. So I highly recommend simply to have a look to all the sensors which we support. The easiest way to see which sensors are supported is after you have installed the EyeVision on your system, you simply can start the hardware configurator in your system, and after it starts, you see here the full list of supported hardware, so that you always get an overview of the latest sensors which are available. Maybe also sensors which are not right now not in the presentation, but we still support it. For example, these LiDAR-based Percepio sensors and some others which simply work with the EyeVision software. You for you as a user, you simply have to select the right camera here, and then you can use it as your point cloud source for your to work with it. But the same is here. For example, the micro epsilon scanner is still supported now. These scanners are not in the list of the presentation for the moment. So, or if you have a special camera in mind and you don't know, simply ask us. We can answer you immediately. Let's have a look to the EyeVision by itself and how it works. Getting 3D and 3D point clouds or 2.5D or depth images. As a user, you have always the same capture tool. So independently, if you have connected a line scan camera, area scan camera, a 3D camera, or thermal or whatever camera, you have always the same tool, which is used to capture images from the camera. So you don't have to think, do I need this special tool for 3D? No, it's always the same. And we have this profile capture. This is a secondary tool which allows to generate profiles out of the captured images. So you get also from a laser scanner the scans by single capture, or you can use the profile capture. This is a special thing then. What is a point cloud and what is a 2.5D image? On the left side, we see the point cloud. This is this colorized image. On the right side, you see this depth image. And why do we have depth image? For some reason, it's maybe easier to work on depth images if you don't, because you don't have the set dimension. But in many cases, it's the first few steps would be to operate on point clouds and then do maybe in a 2.5D image. I will show you an example, for example, dot code reading, where you can see immediately advantage because code reading is more a 2D operation. And the pre-processing of the point cloud is much easier to do it in a point cloud. If dot code means it's, if you know tires, you have these letters on the side, which are in 3D. So the intensity image wouldn't give you any information about these prints because it's black on black. But the Z value will generate height information, and in that case, you have a contrast. Let's name this Z delta information as contrast, and at the end, then you can read it. The advantage of intensity image, if you have on the tire maybe a barcode, you cannot use the 2.5D image because the barcode is flat. You don't get information about that. But then you can use the advantage of the intensity image because the intensity image gives you the color of the surface, and that means you can read this code. So this was a short overview about the principle of the EyeVision software, and now I think we simply start the software and have a look to it. And therefore, today you should have, if you download the version today, you will see, you will have EyeVision 4.0.1. So I have this 4.0.13, but it's okay for today. What we now will have a look to it, how to work with it. And to make it a little bit more interesting, we start with a little bit of point cloud operation. So you see, I use not an official release. That's why there's the big letter no support. So sometimes if you want to test some features, you can also get download links or where you have this no support inside. Then you cannot, you can use it, but okay. I have to remove my dongle here. As you can see here on the right side, this license information is not valid for this version. So with the demo version, you can do always everything. The first thing what you have to do is you simply remove all licenses. And after you have removed the licenses, or if you installed the software newly, then anyway, you don't have a license, and you will see immediately when it starts that there is not the red bottom print. There is an orange one. This means this is a demo version, and so it's anyway better to use a demo version. Here you see it now on the right bottom side. This is a demo version. Why? Because then you are on the same level. Or then we make the webinar on the same level like you have it on your side. So you can do everything with the demo version. There's no restriction in the vision software, also in the image capturing. So if you want to test cameras and so on, or all the tools, the demo version is anyway better. There is no restriction, only the connection to a machine is restricted. But to see if the machine vision software is working as expected, there's no problem with it. So now we see we have the demo version. There's also nothing red here. That means we can start at the end. So I said, okay, please start with the last program. That's why he starts with this setup, also with this user screen. And I would start with the project first today to show you a little bit about 3D and also about depth image, because this was one of our last things which we discussed. So let's have a quick look to our 3D area examples. All these examples here from robot vision to until here to communication demo examples, you can download and install it, and then you have all these examples also. So, and we go to our let's say, I think this one, maybe not. So this is now the tire project. So I think if you have a short idea about tires, you see here, this is a scan of the outer part of the tire. Here you see this small part to which allows you to run the tire very smooth on the car. And here you see all the codes on it. And of course, this is a point cloud. You can see it, you see here this, it's called this OCR tool. It's black on black. If you look to your tires, you see it also on your tires. And here you see, for example, E2. So this is black rubber on black rubber. For all normal, let's say gray or color cameras, it's really difficult. You can organize it with special light or whatever. But if you have not the option to adjust the lighting perfectly, then it's much easier to do it in 3D. So what we first do is we normalize the point cloud. That's why I said it's easier to use a point cloud. We see here the colors, they are moving. That means the gray values, if you do a direct conversion or you use it directly at the depth image, the gray image wouldn't be so good. So the first thing would be, or what we are doing here, we see it, we flatten this point cloud. That's something which is possible if you have a point cloud. And after we have flattened this, we generate these, we use these 2.5 D converter. That means it generates from the point cloud a gray image. And in this case, this gray image. And on this gray image, then we can use again our normal OCR tool. So it makes always sense to use the right tool set for the right task. It's the same like if you have a normal screwdriver and a cross screwdriver. Of course, an old screwdriver can sometimes open also a cross screw, but better is you use the cross screwdriver. And therefore, we have this tool set so that you can select from the tools which are the best tools for the task. In this case, it means if you have at the beginning the point cloud, it's the best thing you use the point cloud tools to generate a perfect point cloud which is flat. And after you have done this, you simply can use the 2.5D image and the OCR reader to do the OCR reading. However you do the OCR reading, either if you do it with a deep learning OCR or with a normal OCR, contrast is always good for OCR or for code reading. Contrast at the end is always good if you do machine vision. The good thing for contrast or for if you use 3D, the cameras have mostly the right light source built in. If you have a normal gray camera, you have to select the right light source. The 3D cameras normally have a built-in light source which fits to the needs of the camera, so that you get you get a real good image quality of your target device, of your target part which you want to evaluate. So maybe before we have a closer look to it, I think I discussed it slightly. Of course, on the left side you have these tools for capturing images. So the capture image tool in this case means capture an image, whatever an image is. Means if you have a line scan camera, you get lines from the line scan camera and they are collected into a gray or color line scan image. If you have a color camera, area scan camera, you get a color image. We have a look later on some other projects where you see you have always the image capture command, and the capture command knows, because you have selected the hardware, this is now a 3D camera. So we take, we grab now either only a point cloud, or depending on the camera, some of the cameras like for example the Intel Realsense, but nearly all of the many of the others have also different. So this camera has a color camera, 2 gray cameras, and a pattern. So you get a color image, some gray images, and based on the pattern generator, you generate also a point cloud and depth image. So the capture tool knows what camera it is and generates for you the right image information into the different image memories. What are different image memories? You can see it here. We have the camera view or image memory, camera viewer image memory. The camera viewer shows image memories. Of course, the camera viewer cannot show the camera. The camera is connected to a system, and the incoming data go into the memory. And there is a viewer, the camera viewer, which shows this memory, which represents the information from the camera. If it's a 3D camera, it shows the point cloud, and here on the bottom side, this is a gray image. It shows simply the gray image. In this case, it's an artificial made gray image based on the point cloud. But if you have a gray camera, it looks identical. And you can also always see on the bottom side, on the right bottom side, what kind of image is here. In this case, you see here, this is a gray image. And here on this side, you see, of course, all the information about the X, Y, Z values. That means this is a point cloud. And of course, you have some additional tools in the point cloud. So that means if you want to know how does these Z values look. So it's because point clouds are more difficult than gray images. We have some additional tools to give you an idea how these point clouds look like or how they are operated. For example, here also you see the size of the point cloud. Normally, if you buy a gray camera, you have, of course, X and Y value of the camera, and that's what it is. And what you also get, this, for example, here 480 by 162. So this is represented by this area which we have selected here. But for the point cloud, it could be nearly any size. This means from 4,500 in height. This is the length of the complete point cloud here, and it's a width of 355. So, but more important for the point cloud is how are these values? And you see here the Z values are from let's say anywhere between 20 to 5 51 millimeters, or you see here the span from minus 4.71. This is here to 30. This is here. So, and if you have a gray image and if you don't do anything, you would see here in the gray image that you have all kind of gray values. And if you have a look, for example, after we did normalization, you see here we have only a very small range of Z values, and especially the numbers are in a way where you can easily separate them. So that's why we have here a good contrast for the code reading. So you have here all this information. Also, if it's an ordered or unordered point cloud, this enables some of the tools to do special operations. You get ordered and unordered point clouds. Maybe you have also a look to the manual. So after you have installed the EyeVision, of course, you have a context sensitive information. If you need, or if you work with the EyeVision software, you don't know how something works, you can activate this context help. And if you open up one of the tools, you get also the tool information. So I highly recommend, if you work the first time or if you have any questions, simply to have a look, to start to open up the online help and get all the information you need to work with the different tools. So to explain how it works in principle, let's take the capture image tool. What we discuss now belongs nearly to all the tools, exactly the same way. That means at the end, of course, the basic programming is you take a tool from here, grab it and drag it into the C column, and then the tool parameter list opens up. In this case, you have three options. One is capture image. That means capture the image from the camera. And then you have two other options: save an image. That means save the image from image memory 1. If you use image memory 1, the tool knows, okay, this is a point cloud. He saves the point cloud. Or if you load an image, a point cloud, it's at the end, it's an image. You can simply select the point cloud which is stored. So all the examples we have stored images, whatever an image is: gray, color image, point cloud, thermal image, and so on. And this load image for the rest of the software does exactly the same. It delivers an image, in this case a point cloud, into the image memory. That's why I said at the very beginning, for the EyeVision software, first of all, there is an image memory, and the capture tool either delivers to the image memory the information from the camera, or alternatively from a file. At the end, it's the same. And that's why you can test everything also without the camera, because you can load these image information directly from a file and operate on it as you have it from the camera. And you see here we have some other options, and so these options are also available for save. So either you always load one file, or you can load multiple files. It's the same, you can store multiple files. Therefore, you can also run a machine for a while, capturing different images on the machine and load them for each turnaround, so that you can simulate a complete running machine with all different kind of parts. So in this case, we load this 3D image. We have here the extensions. There are different options for a 3D. We have the PLY. This is general file format for 3D. It's nearly used for, it's available from nearly all tools. The negative side of this is that the images are really big, and we have two own file formats. One is called E3C. This means it's a compactified 3D point cloud, so it's lossless, stored point cloud. That enables you also to send the projects with 1 or 2 point clouds to us with normal mails. It's very compact. Or E3D, it's a standard file. Or of course you can store it also as an ASCII file, so that each value is stored in ASCII value XYZ for each pixel, which is also a real uncompact format with needs a lot of space, especially if the images are bigger. So at the end, you simply select what you need here, and if you're finished, you simply say OK, and then the tool loads always, in this case, an image. If you select here capture image, it captures an image from the camera as long as the camera is there. And yes, that's how the tool works. Of course, the information you get in the online context help, or you have the complete PDF manual installed of the EyeVision software. So if you click to manual, PDF opens up and you can read the complete EyeVision manual. Might be also an option to get the information of the software, but mostly it's easier to have a look to the context help, and especially it's easier to analyze a ready-made program for the EyeVision. So here we have multiple image memories. You see here different columns, and these columns have different meanings. We will have a look to some other examples in a few seconds, which gives you a shorter overview. What does it mean, or what you can do with these columns? First of all, I want to explain something. Of course, here are the different tool sets. Today we will have a look mainly on these different tool sets. Of course, we deliver always a lot of new tools which are not released, but you can test it. So if you see this beta toolbox, you can try the toolbox, but you have also taken care that maybe these beta versions have some minor bugs. So therefore, you can try it, and if it's not working as you expect, let us know and we fix this. But in many cases, it's interesting only to see where we develop right now. So you drag and drop the comments. That means you take it from here with the left mouse button, drag it over and release it. And then it is in the C, the comment column, which will be executed. If the program runs, you can use it, run multiple, or run the complete program once, or do it step by step. That means if you click each time here, we load a new point cloud. Now we do some pre-processing, so you can exactly see what the tool is doing and how it's working. So if you see it here, we mainly did the XYZ orientation to see where it starts, and so on. And so now we rotated it, and here you see exactly how you can go step by step through the program and see how the program works. So these are the tools to operate on the programs, to see which tool does what. Yes. And of course, you can select an area which you want to operate. So you can simply select it and run exactly this marked area. So that are the main tools from here above. This one here generates a new program. This one saves one, and with this one you can open it. I think it's self-explaining. If you have a connected camera, I don't have it for the moment, you can always start a live image to see the live image from the camera. As what I just showed you is if you press the left mouse button in the empty space, the program runs until this space, this position. So if you want to run the program only to this position, you click to here and you will see now it's executed until the next, to the next step. So you can step on here at this position from now. So the first column is more for debugging issues. Of course, it's line oriented, so you can always insert and copy and paste stuff if you want, but we have always here also the debugging stuff, not in my current version for the moment. So here you can give the program the information if you want to stop in some, if you want to debug stuff, or if you want to execute the program only in configuration mode. What does it mean? You can generate different user interfaces with the software. So we have here 2 user interfaces. I'm not sure if the other one, okay, it looks a little bit different to the one we saw. To show you some one example with different user interfaces, I take this gray one. So we don't do for all the projects ready-made user interfaces. That's why I use this gray example user interface. I think it's clear because it's the same software. You can do it also for 3D. That means, so this is a user interface. So for the end user at the machine, he can say start and stop. And here, this is only an output for the related to the demo version, because this software tries to communicate with the machine, or in this case with another program. In this case, the web interface, and as I mentioned, all the communication to external programs are limited in the demo version, but that doesn't matter. It's only that you see, okay, it's running anyway, but it's doing it not all the time. So this is, let's say, the user screen for the user at the machine, and you can put behind of each of these buttons some users with login parameters and passwords, so that not everybody can change it. So, for example, if you activate the password system, then you need a password if you press this button to go to the next step. In this case, no passwords are activated. That's why I directly change, in this case, to the configuration mode. Configuration mode here, in this case, means, of course, you can start, for example, the tool, but you have here a very nice option to modify, in this case, the search radius or the number of T's you are looking for, or you can also have different other parameters from the program by itself. So you have all these options, and that means you don't have to explain everybody a program. You can give him only the necessary parameters which he needs to run the machine. This means if you say, okay, sometimes you have different diameter of the gear, then I give him the option to change the diameter to the new gear. So I could do this also either based on a slider, or you could do it like here with the tools. You can say, okay, we have only a number of tools or diameters to select from. Or at the end, you can also say if you do, if there's a password, you have to enter a password. You can go back to the programming interface. So now you see it's the same like in the 3D stuff. We have this now the programming environment, which allows you full access to everything. You see here the complete program. This is, and if you look to it, the complete inspection program, like in 3D, only with a 2D image. And of course, if we run it here, we see, I can stop it for the moment. You see here, the software tries to transfer images. This is this one here. And image transfer is a communication process. That's why we do not, we do not transfer all the images. We do most of the images, but sometimes, as you see here, we don't do it. So we have between 1119 and 54, we transferred everything and then we didn't transfer it. If you have a machine, that's not good. You cannot use it as a, for your full inspection, but for your 100% inspection, but you can see, okay, the communication with the machine is working. And if you add the dongle, everything is transferred and you're sure it's working. So you can really test everything with the EyeVision software. Why do we have this image transfer here? I could, to explain it to you, I would simply open, in this case, the web browser, any web browser you have installed on your system. If the web browser is anywhere on a system in your factory, you have to know the IP address of the EyeVision software. If it's a smart camera, you have to know the IP address of the smart camera or of the PC. In this case, it's on the same machine. That means you can use the local loop interface of of Windows or of the Ethernet, so that you have a direct access to your system here on the same PC. And now we have here a web interface for the EyeVision software. Based on this web server, you can control all EyeVision systems over the Ethernet if you allow it. And now you see also why we have these image transfers. We have to transfer the images and everything over the Ethernet to the web browser. In this case, of course, over the Ethernet, this means it's a local loop, but it would work anywhere in the system. And we see here, we have here the 735, and here is 508. That means some of the images are not transferred. So if, for example, to test the web interface, you don't care about this not transferred images, but you can see anyway it works. And that's true for all PLC-IO, for Profinet, Modbus, Interbus, RS-232, everything. It's working, but not completely, so that you can test it as well as with everything. The only reason is why we stop it to let you, if you want to use it for a productive environment, that you latest, then you buy the EyeVision software from us, but you can test it. So, and how does it work with these user interfaces? So we can go back also to the process mode. That means for the user, so as long as it's a dongle, we get this output, but we don't care about this one. We have these different user interfaces and you can make it by yourself. That means whatever you want to give to the user, configuration menu or whatever, you generate with the layout editor here, the fitting user interfaces, and you store it. And if you have a look to the layouts, then you see here we have a number of different layouts. So for example, you have the configuration layout, or we have the integration layout, these are only layout, only displays. So we have also nice gawks and everything to generate nice user interfaces for the end customer. That's what I wanted to show you when I showed the 3D, the 3D, that how many camera viewers or here buttons and everything you need. You simply generate it. You have this layout editor, which allows you to generate buttons and everything what you need. For example, if you need here a button, in this menu, you simply go to the process button and you say, okay, I need here a start button. And if you press this, then you have a start button. So if you have, I close this. So if you have a look to these ready-made menus, this is a simple start button. It's only a layout with some elements, and you can store it and tell the system, if you start this or that, then we want to be immediately here. Or if you need the main menu, you can also put it on a button. You can do nearly all kind of user interfaces directly from here. Let's have a look to some other 3D stuff, because today we are more in 3D. So we had a look to this tire stuff. Let's have a look to our, let's say, bin picking, for example. And I really can recommend that you simply try it. And here you see we have this point cloud, and we recognized in this case which parts are where and what. So for example, the bottom part, if you have a gripper for the bottom part, maybe you only select the bottom parts here, and also the airspace so that you can grip it. And more interesting is, in this case, if you run it again, you see each time we run it now, we load a different point cloud. If you have a look to the capture image tool, now we have used load image cyclic. And cyclic means each time we execute it, we load the next image from here. So that at the end, it's like you have a camera. The image is loaded always from the file in this case, but of course these images are captured from a camera and then stored in successive images. So first of all, you can do the programming also offline from the machine. That's nice, but more important, and that's why I explain it always, is if you need some help from us, it makes sense if you send us these projects with some images so that we can see your problem. So what we really recommend always is to start with creating an image and a project, and then storing some images, and then starting on these images to the programming, or you use one of our pre-made projects here, and modify it to what you need effectively. So, for example, in this case, I would say let's have a look to Mittelwelt, to our to a profile application, and in this case, let's run it once. Okay, so this is a scanned, a pre-scanned welt, and we see here on the very top a blue line. Hopefully everybody can see it. And this means if we run it now, we see the blue line is running. This is like we saw these triangulation scanners here. Any of these, let's say, take this one. So each time this scanner grabs an image, it generates one of these lines, and then you can connect these lines to one image. And as you can see it here, these are, upsala, where is it? I have to move it a little bit. Now here you see each scan line of the scanner. So at the end, based on multiple of these lines, we get this complete 3D image. And with this profile tool, we simply read out each line. That means we can simulate the scanning process, or you can simulate also the scanning process. That means even if you have this kind of application and you need help, you have to scan one of your products and send us at least one of these lines. Of course, what I didn't mention before, you can use the surface mode. Then it looks more like an object. That means we do some triangles everywhere and generate a flat surface. In reality, as like all scanners, we have discrete lines and we can connect them. And here you see, for example, this is the weld, and here we see a minor defect, and this minor defect is here. It's exactly this one here. So you can also go to surface mode, and then this fits more to the part. So it was on the wrong side. You see here this dent here, and we detected this dent as an error, and you could do anything. So in this example, we simply display it and run through the complete weld to simulate and show how it works. And as you can see, also for this kind of application, you can really easy make this kind of difficult or really challenging application. It looks like nothing, but it's really easy to solve as a solution. So yes, let's have a look to the other columns which we skipped before. So we have on the first column is E like execute. Here you see we have this stop sign. This means never. That means never execute this tool. This tool simply waits 20 milliseconds. If we add this tool, you will realize it runs not so fast. Or if we increase simply, let's say, increase it to 500 milliseconds, then we have, if we run through the tool, then it's moving very, very slowly. So if you want to control the process or whatever, then you can make at some positions these, let's say, time constraint into your software. More important is you can simply deactivate it, and then you see it now. It runs with full speed here through the complete program, and you cannot see how it operates. You have some other options, and this is where we arrived here, is only in configuration mode, only in process mode. Maybe you remember we have this, let's say, process screen and this configuration screen. You see here on the bottom, this belongs to the user interfaces. So with this constraint, you can simply give the system a hint. Okay, look, this tool should only be used or executed in configuration mode, if you have this mode, or it should only be executed in process mode, or more important, only in configuration mode with debug, so that of course, you can generate some outputs or whatever if you want to see how the software is working, and maybe you want to have the option to activate it very fast. So of course you can add at any time these output lines where you print something anywhere. Or you say, okay, I only want to do the outputs in some certain situation. Then you can say, okay, only when the debug mode is on, it's activated. That means now it runs in full speed, and because we are not in debug mode, and if we are in debug mode, it's moving very slowly, as you can see. So that's a real nice option to, without modifying the program, to get more output output from the program, to simply let's say see what happens when, or if something is not working as expected, to get the information either on a display screen here, or or you can send it also over the over Ethernet to any debug monitor, where you are then informed when something happens. So this is an execute column. The graphics and text column have the option either always or only in case of okay or not okay. This this means these overlays are displayed or not displayed, or they are displayed only if it's good or if it's bad. If you have a lot of tools in your software, that means you have a lot of overlay stuff, and maybe you don't want to see all the overlays always. That means you can deactivate the overlays simply if you click to it and you say never, then you never see something, or you see only if it's not okay. So now you see here, I said only if it's not okay. Now we have this red because it's not okay, and at a certain point we get it back. So let's run it for a while, and then yes, and the same is for the text output. The text output gives you the information of the tool. What is the tool doing right now? And the text output generates the output into the log file. The log file is a really helpful information if something is not working as expected. You can select which informations you really want to see. So the less you have here, the less are displayed here. And it helps you, first of all, to see if the program works, and maybe only if there are some errors, or if you have some normal outputs, then it's an normal output here. So if the program runs, you see all the information. And more important here, if you start up and something is not working during startup, you can see what is not working. For example, if the camera is not working, you have here in direct information, maybe a driver is not found or whatever. And if you cannot figure out what's going wrong, you have always the option to save the log file. And in that case, all the contents, even the not displayed stuff, is stored in the log file, and you can send it to us, and someone here can have a look what's going wrong in your system and why it's not working. So therefore, first of all, the output of the tools are displayed here. But more important, in case something is not working and you need some help, you have the option to save the log file, send it to us, and an engineer from us can have a look to it and give you a hint, or see immediately, okay, that's a problem why your software or your task is not working as expected. So that's the text tool. And of course, you can activate it or deactivate it. In most cases, because all the modern systems, let's say all the systems within x86 are so fast that you can run it always. Of course, all these storage, saving and handling all the information needs some computational time. That means we recommend not. That means it takes CPU time. If you have a slow system, like maybe a smart camera or a small embedded system, like maybe a Raspberry Pi 2. The latest Raspberry Pi is also a fast system, but let's simply name Raspberry Pi 2, a very old one. Then this you can simply save time if you deactivate this tool, and then the data are not stored, and it saves a lot of CPU time. But in most other systems, you simply don't care about it and run it as it's set up in the system. So you have E for invert. That means with invert, you can invert the result column. The result column has the option. You can all the results, you can test all these stuff with the interpreter control tool. That means depending if it's good or not good, you can do jump to mark, or jump in case okay or not okay, or warning. And here you see if the LED is green, that means okay. If it's gelb, if it's yellow, it's a warning, or if it's red, it's not okay. And so sometimes you say, okay, I don't care about this one. Then you can simply deactivate the result of the tool, and it's not used for a total result collection. Or if you say, okay, this tool normally generates an error, but an error is good, then you can simply invert the error and you have still a good result, because you want to make a box around the tools to say, okay, if everything is good before jump, or if some of the results are not good, then don't jump. And either you say, okay, if it's always in good cases it's bad, then you can invert it. Or if you say, okay, I don't care about the result, for example, of the stopwatch, then this result is simply not used. About the C column, we discussed, I showed you a lot of stuff until now. Of course, if you use the left button, you see immediately the tool configuration opens up. But more important, if we run it again, and if you have a look here to this to the camera viewer, each time I click to it, you see the image contents change. This means, why does it do this? Because if you simply click with the left mouse button to this one, to the tool, the program is executed from the beginning to this position, and in this case it's an image capture or a profile capture, and it captures the next profile here from this profiles, so that you have always an up-to-date image. But for some reason, sometimes you don't want to do the execution, then you use the right mouse button and use quick edit. In this case, it's not modified because only the tool menu opens up, and you can change the tool's parameters. This is in some cases really helpful, especially if you have really big programs, and if you want to change something here at the end of the program, you don't want to wait until the program arrives here at this position, for example. More important in the C column is, and I simply recommend you have a look to the description. you can see here the show parameters. This is one of the most powerful tools or most powerful options in the software. This means these are all the parameters which are available of each tool from externally over Ethernet. So you can modify each of these parameters over one of the network connections, mostly Ethernet, but it's also working over RS-232 or USB or whatever. And so you can change it directly from anywhere in the network if you have granted the access to the system. Or, and this is also really nice, we have this script tool inside of the software, which enables you to program in a basic script manner things. For example, if you want to change the point cloud source or anything else, you simply can click to it, and you see here you get immediately a small snippet of the script programming language, which allows you directly to change this value here. In this case, you set it. If you want to read it into your script, you simply change it to get. Or if you say, okay, I want to control it over our remote interface, you say you simply select this one, and then you get this the snippet which you have to transfer over the connected network to the system to change this parameter. That means if you want to change this parameter, so not get, we want to set it, then you simply use this snippet, transfer it. Let's say we use Ethernet, you transfer it over Ethernet, and instead of value, you enter here the new value of this parameter, and this parameter is directly changed in the program here. With this, you have the option to do all kind of remote parameter change at any time from any system, from the same system or from any other system which is connected over one of the networks you have. So, and depending on the tool, sometimes okay, this command has no register information. Maybe we have also no register. Let's say we have here no register information. We need any other tool. So the communication between the tools, I didn't mention it right now, runs over registers. That means, let's go to our 2D project because this is nice. And we have some easy registers. So let's go to the WebGear project from before and discuss about the register parameters and the data transfer in principle, which is also one of the important things. Of course, we start here with this standard tool screen. So you can start with any other if you define it. So let's say the blob tool. The blob tool has, for example, a value register, how many blobs there are, and the objects, for example, this green one, the X and Y value. So what does it mean? This means if you want to operate on these blobs, another tool can take these values from the register. Here you see a new calibration, and we get this new calibration. In this case, the origin, the center point here, is done based on the register of register 0. So what does it mean? Or how is it working? Let's open up the value register and the point register. So now I run it to this position, and we see we have one object, this one here. This object has one XY value, this one here. And we want to have the coordinate system in the center point of this one. So how to transfer this to another tool, in this case to the origin tool. Simply the blob tool here stores this object here in on top of the point register, and of course the calibration tool, we tell him look in the point register on the top value and take this result. And the result of this is now the coordinate system. I just activated it, that you can see it. The coordinate, because I activated here draw axis, the coordinate moves directly in the center point of this wheel, of this blob here. And based on this, in this case, on this coordinate system, it's a 2D only. To explain, we are not in 3D for the moment, but it's exactly the same for 3D, only with the Z value additionally. So in this case, we take this one here, generate the coordinate system to this one, and then based on the EyeVision software itself, for example, the circle tool depends on the coordinate system. That means the position of the circle tool is relative to the main coordinate system. Because the main coordinate system is moving, the circle tool is also moving. And that's why, if you have a look to this circle, that's why this circle is moving. And of course, if I run this, and if I move the radius here, you see the radius is going to be bigger and bigger and smaller. So we can have also a look now to this other tool, which I mentioned before, that you have access to all the parameters. So the circle tool, of course, have a parameter list, and one of the parameter list is the radius of the circle. And how do we modify this radius? Of course, first of all, we read out the radius, and then here we simply set the value of the circle register to the new value of the readout of this slider. So you could also modify the size of this circle, either if you use the script tool here, and here you see. In this case, we read out this radius, the radius button. You see it here, and at the end, and at the end here, we write it back to the diameter of the circle tool. Or you could also, of course, use you could use the parameter list here and select the right source and say set, and you get immediately this, if you go to the remote interface and you simply change here, send here a value, and the value would change here in the circle register. So you can do it from anywhere outside to change this easily. And of course, because it's always the same software, this works also with 3D. You have exactly the same parameters. Of course, in 3D you have some more parameters, but it works exactly the same way. And and that's why I really mentioned you should always make a project, store some images and your program inside. So if you send us, for example, if something is not working as you think, and you send us a project, like in this case 2D web gear. This is if you want to see where the projects are, you can go to here to show data directory. Then you arrive. Let's move it over here a little bit. Then we open up an Explorer or a file viewer from Linux and you are directly in the installation, in the not installation of the EyeVision, in the user space where we store our stuff, and you can go to projects and let's say we stay here at 2D web gear, and you simply make a zip file out of it and send us this zip file. And then we can open up and see exactly what you have and can help you with your task. So what means a project? A project means it's a summary of all information which is needed that EyeVision can do a task. So let's say we make a new project, and also here you have the option new project. Yeah, so why I recommend I showed you the show data directory. Why I recommended this one, because normally, of course, here we have a Windows system, and no, not this one. Okay, let's go immediately here. We have a Windows system, and we see, okay, this is installed on C, as Windows expected, program data EVT EyeVision. But if you have a Linux system, the location is different. It depends on the distribution and everything. So with this show data directory, you immediately hear where your projects are, or where all the EyeVision stuff is. And if you go to projects, then you have the projects you want to make. So, and if you go here to new project, then you can simply start with a new project. And in principle, as you see here, this is a naming convention. You can name your project XYZ, whatever. Normally, to distinguish between 2D, 3D terminal, we start mostly with what it is. Let's also start with, let's say, a 2D test web webinar project. So if we say this, then he says, okay, the old project has been modified. Should he change before he starts a new project? No, we don't want to save it. And now he generates this new project. And if he's finished, you will immediately see here 2D test webinar. We see here our standard setup. So by default, we have reset to configuration or process mode if you don't know where you are, but we have no other layouts here for the moment. And of course, if you open up a program, no program here, no nothing. Where do we find this project? If we go to show project, go to the process menu, projects menu, we will see immediately here, let's say we change it by date. So this is from today, the 26/11. And if you open up, we have here this default project. As you can see, everything is in default. Here, no programs inside. Here, no images inside. Also no reference images inside. Everything is in default. If you have some documentation for the projects you are working, you should store it here. The only thing what we by default install are two bitmaps. So if you want to have a nice background for your application, you can store the background, or you should store it here. So if you want to now, normally we start always with one layout. So you start up with the layout editor and you say, okay, I want to have a background image. So I can only select this one. If you have copied another one, you can use whatever you have. So you have this one here. And maybe I want to work with 2 or 3 image memories. So I simply generate another image memory. Maybe because I have 2 cameras, or I know I have an intermediate image. And when everything is so far good, we keep this and we say save as new. And because this is my programming environment, we name it normally development test web. and we close it. So, and now you see here we have a new layout, and it's also active. It's test web interface. That means if you select this as your default interface, each time you open up this project, you arrive exactly here. And from here you can do whatever you need. So, and normally you have a connected camera to it, and you start with storing some images on which you can work. Of course, today I would say we simply organize some images from here we should have in images some whatever images, let's say training, and we copy it to our new project here. And of course we can now do some image capturing. So either if you have a camera, you select the camera. If you don't have a camera, you can simply say, okay, now load, cyclic. And if you go to training reference, that's the folder which we just copied inside here. We select this, and the nice thing is now, okay, you see we have activated image memory 1. That's why we have it here and not here. I didn't mention the image memory column is on which image memory the tools are working. So the capture tools works now on 1. So of course it's easy to change it to 0. And then we get the images here. And it's now like you have a camera and something is moving under the camera. It's exactly the same. There's no difference between capture and load. Of course, the difference is you don't have a triggering source. Of course, if you have a camera, you can say, I need a flash, I need a trigger, and so on. Of course, you don't have this option if you do it with if you load the image. So at the end, you save your first program, like count object, for example, and now we don't count, we simply capture. So let's do one simple project. We count the white objects in this case. And of course, we are still not active. Okay, make it here. This is the active camera. Here we use always the active camera viewer. So now you see this is the active camera viewer. All the other camera viewers have this other icon. So now we open it up, and we see here we want to look for the white objects. And we have a lot of other features here. Now, 255. So, and we go this way. So test. So in this case, we have 3 objects. We have the background and these two objects. Normally the background is no object which you want, so you can ignore the boundary objects. You have 2, and now we have our first small program. If you remember, we have this data viewer, so we have a value register, and we use also the point register. And if you run it, we see we have 2 objects here, and we have the two objects here in the point register. For 3, if you have a look to it, there are some other additional registers like global string, point list, circle, line, 3D register. The 3D register is really, really big. So And because you have the X, Y, Z values and also rotation values, that's why maybe for the, for the first steps, a 2D application is good to have a short idea how it looks like and not be overflown by all the 3D stuff. But anyway, so this works, and with this we have our first project made. If we go now to our to the folder and have a look to the programs, and we see here our count object is here. That means if you need now help, if you make a zip file out of it, we have the project, we have the images, and of course, if we have also all your layouts and everything what you have, so that you can see what you have done and why it's not working. So that's so far. Of course, the comment section is important also from the program editor, especially if you use the remote stuff. You should really name it. If you have only a load images as capture, for example, and here count white objects. You should do this for that you by yourself know better what the tool is, but on the other side also, this comment section is also used as a reference if you access the different parameters from externally, because you can have multiple blobs, and each time you move the blob inside, you see here we have count blobs the same name, and then you would change all the parameters directly from all the parameters with the same name. That's why you should always change the comment section to what you do. It makes also sense if you say, okay, the first comment normally is capture image from camera. I assume I know this the camera belongs right now to the zoom tool. So you can say, okay, so he didn't get access to the camera. That's why we couldn't do anything. So let's say either you say, okay, we are now in programming mode. I don't have access to the camera, and then I deactivate it, or you say, okay, we are in configuration mode and I want only have access in process mode. That means now this tool is only executed when we change to process mode. So immediately that helps you also to distinguish if you don't have a mesh-in, you take the images from the file. If you have a mesh-in, of course, you are in process mode. You capture the image from the camera, because in the process you have a camera. So that's what we really recommend. Generate your project, and first of all, everything is collected together in each project. So if you do different solutions, you have different projects, and you're sure you have always for the different tasks all stuff together. And the other thing what I also want to mention is, if you have real big questions, not only maybe you have 5 connected cameras to the system, you have the option to connect as many cameras as you want, and some other stuff, and you have a very complicated question also about the hardware, then the project alone doesn't help us. In this case, you have to create this support file. This is a small wizard which helps you step by step through all the information which we need to help you, for example, also for the connected hardware, like maybe you have a 3D camera from AT, a 2D camera from Basler, and a thermal camera from FLIR. Yeah. So we need to know, if you have questions, we need to know also information about these connections of the hardware. And if you go with the wizard through all this information is stored in a zip file. And if you send us this zip file, we have, of course, the project file. In this case, the test webinar, because this is an active project. But we have also information about the used operating system, what CPU is inside, and so on. This is really necessary because, as I mentioned, the software runs on all kind of, not all kind, but on many different hardware platforms like x86, Intel or ARM or RISC. And it runs also on, if it's an Intel CPU, you can run it on with Linux or with Windows or Linux, with different Windows versions, of course. And on ARM systems or RISC systems, it runs on Linux. And so also which Linux distribution, because in many cases, the relation between the operating system, the EyeVision and the driver is key. If something is not working, that's in that case. If you have really problems also with the hardware, you should make this support file, because then we have an overview about of everything and see, maybe it's an old driver inside of the system which is not working with the camera or with the EyeVision software and all this other stuff. That's why I recommend, if you have not only questions to your program, also about the hardware, you should go to create support file and generate a full support file with everything and send us then the zip file out of it. And then we have a full view to all your questions. So maybe, so for the end, we are slightly over the time, but anyway, I highly recommend that you have a look to all these examples. We have a lot of nice examples. So for example, this box volume thing, which calculates a 3D area point cloud solution, which shows you time of flight camera. And you see here how the packaging is done and how much rest volume is in the box, which you have to fill up with filling stuff and so on. And yes, or if you, so I showed you the robot vision stuff before, but maybe you have what might be nice here, the CAN inspection example. So this is to see if these are point clouds of normal cans like Coca-Cola or Pepsi or whatever, and if the can is the pressure is correct, so the height is determined with the full speed of the production belt, and this is also a real nice application and how it's made. So here you see also, if of course you don't see it right now, but so we operate here also on a depth image additionally to this one here. It depends on what you want to show to the customer. As I showed you the example for the gear inspection, you can make your special quiz, or of course, if you don't want that the end customer sees that EyeVision is running, you can run EyeVision as a runtime system in the background, and you simply transfer only the image data to your main user interface. Then nobody see that as a view that EyeVision is running in the background. So this is also an option. As you might have seen, this is done simply if you go to the hardware configurator, the system asks you, do you want to run it with a user interface, or you want to run it as a runtime interface? Runtime means EyeVision starts totally in the background and you can control it over the remote interface directly to load a special program or unload a special program and so on. And yes, so I didn't select it one. And so also for the runtime systems, you can select which hardware is fitting best to the EyeVision software. And of course, you can run one user interface and multiple runtimes. So as you see, it opens up always the last project, but this you can configure this everything here in the application parameter. I didn't go through the application parameter today. You can control in the application parameter what hardware you want to use, and a lot of other stuff. What PLC I/O you want to use, and the program editor and everything. Maybe you have to you have a look to our basic seminar about EyeVision with all the basic details, how it's working, or you have all these communication tools to communicate with other processes like Profinet, EtherCAT, Modbus, Ethernet IP, MQTT. So you have all these communications to directly communicate to a PLC or to other systems. And of course, you can run multiple runtimes with multiple cameras so that you have a complete parallel running system. It's a lot of there are a lot of things which can be discussed, and maybe we follow up also our basic webinar, which shows you exactly all the basic things which I slightly mentioned today. In more detail, how to set up all the parameters of the EyeVision software. So, of course, we had a short look to the point cloud and how to connect the software to the sensors and everything. I hope it was somewhat interesting. If you have any questions, feel free to send me the questions by mail. I hope it was helpful, and I hope I can see you in one of our next webinars.